Hi everybody. All right, lesson 2 on solving equations. So in this lesson, we're going to be continuing with what we learned in the previous class. The only difference between these questions is it's going to take the form of ax plus b equals to c. And once again, in previous years, you've seen this before. So if I have a question 5x plus 4 equals to 14, you've seen this in the past because to isolate this, you need to move the 4 and then move the 5. So we know we have to subtract by 4, giving us 5x equals to 10, and then when we divide by 5 to both sides, we get a value of x is equal to 2. So in today's lesson, it's going to be very similar to that. We only have to make sure we're working with fractions or decimals, whatever the question asks. So in this first problem, we have 2x plus 10 equals to 3 over 5. So we're going to start by moving the 1/10 over by subtracting both sides. And then this will leave us with 2x equals to 3/5 minus 1/10, which will mean 2x is equal to, and then when we subtract fractions, we want to make sure we make a common denominator, which will be 2x is equal to 5 over 10, which can be further reduced to 1/2. And then we're going to divide by 2 to both sides. So x is going to be 1/2 divided by 2, which means x is going to be 1/2 times 1/2, which is 1 over 4. Now, again, we can always use these to check our answer. So we can say if I know x is 1 over 4, then it's going to be 2. So check. It's going to be 2 times 1/4 plus 1/10. This is going to be 1 over 2 plus 1 over 10. And then when we add that up, this will be 5 over 10 plus 1 over 10, which then is 3/5, which matches our answer. Now, what you'll notice is I showed every step, and I'm going to show every step, as many steps as I can in a video. When you're actually doing the work, you don't have to show every single step like this, but some steps will be necessary. Okay, now the second question looks exactly like the one in the previous one, except I'm going to actually show you a different method of doing the same problem. So we can always move the 1/10 over and then divide by 2. In this question, you can move 1/2 over and then multiply by 3. But I want to show you a different method that can get you to the same answer. So this method includes, first of all, we have to make the fractions all improper. So in this case, I'm going to make it negative 7 over 4. Now, another way of solving these questions is by multiplying by a common multiple. So when I look at 3 and 2 and 4, I ask myself, what's the common multiple of those numbers? And a common multiple, in fact, the lowest common multiple in this case, is going to be a 12. Now, one trick that we can do, once we know that this is a 12, is multiply every single fraction by 12. So I'm going to multiply this by 12, multiply this by 12, and I'm going to multiply this by 12. So in math, we're allowed to do anything we want as long as we do it to both sides of the equation. So I'm going to do it to this side, multiply by 12, and then multiply to the left side by 12. Now let's see what that does. When I multiply 12 times this k over 3, this is going to help me simplify. And the important part you'll notice is that the denominator is gone. I'm left with 4k, but the denominator is gone. Same thing over here. The common multiple of 12 will help me cancel out this 2 with this 12, leaving me with a 6. The denominator, again, is gone. This last part here, with a 12 over 1 and then a 4, I can reduce that to a 3, leaving me with a negative 21. But the important part here is that the denominator of 4 is now gone. What I have left is an equation that looks really weird. I don't know what happened there, but we have an equation that's just integers, and we no longer have to work with fractions. So I can now just add 6, leaving me with 4k equals to, that looks like it's negative 15, and then we're going to divide by 4 on both sides. So negative 15 over 4, and then that is all I can reduce. So this is my solution. And then once again, I can check it if I wanted to. Okay, our last example. So here it says Colleen has a phone plan that charges 5 cents for long distance calls. There's 1 month fee of $4.95. 1 month, Colleen's total charges were $18.75. How many minutes did she make? So these questions are very similar to what we did in the last unit with linear equations. So we can set up our own equation that mimics this. So in this example here, we don't know the number of minutes. So we're going to say x is going to be the number of minutes. And then the other thing I would kind of make a note of is that it's $0.05 per minute. And then I also know that there's a constant of $4.95. So what this $4.95 means is that you will always be charged $4.95 regardless of how many minutes you call. And that's very similar to a previous unit where there was like a fixed cost of taxis, and then every kilometer you traveled you had to pay more. So this is very similar to that kind of problem. So now once we set up this equation, we set it up by saying it's 0.05 cents per minute, and we don't know the number of minutes, but we also know that there's a constant value of $4.95, which is going to be equal to the total cost of 18.75. So, and this equation makes sense because 0.5 cents per minute, or sorry, 5 cents per minute, plus an initial cost will give me a total charge of 18.75. So then we can just start to solve. So 0.05x equals to 18.75 minus 4.95, and then that will give me a value of 13.8. And then we can divide both sides by 0.05, giving me a value of 276. Now, when we do word problems in this unit, you have to write a sentence, otherwise I won't know that you know what you're actually looking for. So we would say, Colleen used 276 minutes that month. And then we can check it by saying 0.05 times 276 plus another 495. And then once we go into our calculator and check that, we do in fact find that it is 18.75, and we know we are correct. Okay, and that's it. So try these two on your own. You can, for this part B question, you can use either method. You can either use where you move the fraction over to the other side, or you can try this new one and see if you end up liking it better. Multiply everything by the common denominator so that you're left with just integer work. Okay, see you later.